In this video, we'll talk about multiplying monomials. So first off, let's talk about what a monomial is. That seems to be an important thing to talk about. So if we're looking at monomials, well, mono means one, and the meal part in math means term. So some examples of monomials would be, well, 7, that's one term. X, that's one term. 7x, also one term. If I had 3x squared, also one term. However, if I look at, 2x to the fourth plus 7, this is not a monomial, it has two terms. So a monomial would be any of these as an example, and it might be more comprehensive than that. Basically, you can use multiplication, you can use division, you can use powers, just no addition or subtraction. So before we talk about multiplying monomials, let's talk about exponent laws. Just a quick review of a couple of them that we've seen before, and we'll just do a quick review here. So if we're talking about a product of powers, so as an example, if I take x to the m power times x to the n power, that would be x to the m plus n. Note that these two numbers have to be the same. So if I'm looking at 3 squared times 3 to the 7th, well, this would be 3 to the power of 9. I can just add the exponents as a shortcut. Because another way I can think about this, so this is 3 times 3. That's what 3 squared is. And we can rewrite this guy as 3 times 3 times 3 times 3 times 3 times 3 times 3. Notice there are 9 3's here. 3 to the 9th. Or we could take the shortcut. This would be 3 to the power of 2 plus 7, or 9. Okay. Another exponent law would be the power of a power. So this one is if we have x to the power of m all to the power of n, well, this would be the same as x to the power of m times n. So an example here, if I have x squared to the power of 3, well, if we're using the shortcut, we think this should be x to the 6th, because we're taking x to the power of 2 times 3. Now, what we can think about this as, if we break it down, just working it to prove it to you. If I think about x squared, I'm going to cube that. That's what this is. So it'd be x squared times itself 3 times, which each of these in here has x times x. So we can write it as x times x. That's one of the x squareds times x, the second of the x squareds, times x, the final of the x squareds, which would be x to the 6th, because I have 6 x's all multiplied times each other. Or we can use the shortcut, just multiply these two numbers, go straight to the 6. Okay, now that we've reviewed that, let's do an example. So this will be kind of what we're looking at. We're looking at two different monomials here, and we're multiplying the two of them. So the first bit, if we're trying to simplify this expression, we have to consider this piece first because of the exponent. So before I can do this multiplication right here, I have to do this exponent first. So let's do that. We're going to square this whole piece. So I'm going to take the 3 and square it times itself, the a to the 4th and square it, and the b to the 2nd and square it. So this is where we can kind of use that power of a power rule. So this will become 9, because 3 times 3. And then we're going to take a to the 4th and square it. So in this case, we're taking power of a power, so we multiply the exponent. So it's going to be a to the 8th power and b to the 4th power for very similar reasons. That's what this is equivalent to. And then I'm just going to keep this guy the same for the moment. Now, if we look at the green and the yellow expressions, there's nothing more we can do with them individually. However, since multiplication is commutative, I could rewrite it like so if I wanted to. We could do the numbers here. 2 times 9 Then we can do the a's, because they're like terms. A squared times a to the 8th. And we can do the last variable term, which would be b cubed times b to the 4th. Now, I wrote think there because you might not necessarily write this out every time. I'm just illustrating it for the example, that I've literally changed nothing about this problem since multiplication is commutative. It doesn't matter what order I do it in so long as I do it. So if I'm looking at this, I take the 2 times the 9, I get 18. I take a squared times a to the 8th. Remember, if we have same bases and we're multiplying them, we add the powers. So this would be a to the 2 plus 8, which would be a to the 10th. And then likewise, b to the 7th. I'm going to add the 3 and the 4. Now this expression is a simplified version of this top one up here. There's nothing more I can do until someone tells me what a or b is. So this is as good as it gets for now.